Hey guys, Mr. Katz here. Just wanted to do a little bit of lesson 2 because a lot of you were absent today because of the field trip. We're going to go through this pretty quick, so if you ever need to, please pause the video. We're going to do the whole lesson, pretty quickly. But again, just pause the video if I'm going too quick. Yesterday, just a quick warm-up. We did this yesterday, but in case you missed it, question was how can you use the zero product property in order to solve this problem? So go ahead and pause it, and then when you're done with it, check how I do it. Well, here, because you have a factored form, but it equals not 0 but negative 18, you would have to multiply these out. 2x and negative 7x become negative, it should be negative 5x. And minus 14 equals negative 18. Then you're going to move the 18 over by adding 18 on both sides. You're left with plus 4 equals 0. Now that you have a quadratic equal to 0, we can factor this side. Things that multiply to positive 4 that add to negative 5. Set each one of these equal to 0. You get your two answers of positive 1, because x minus 1 equals 0, and x minus 4 equals 0. You get x equals positive 4. And there are your two answers. All right, so lesson 2 starts off with, well, actually, this was the homework, which we went over in class. And if you have any questions on that, we're happy to go over it. Here is packet page 7. Right? So basically, it says that when solving a quadratic, you have to find all the values of x that would make the equation true. So if you have x squared equals 25, what values for x would make it true? Well, if x equals 5, 5 squared is 25. But also, you could have a negative 5, because negative 5 squared is positive 25. So those would be the two values for x that will make that equation true. How could you use this algebraically? Well, how would you get 5 based on 25? Well, basically the opposite of squaring something is to take the square root. So if you want to know what x is and it's being squared, if you want to cancel out and set it just so that you have 1x, we take the square root of both sides. And the square root of 25, even though on your calculator it will say 5, you have to know that it could either be a positive or a negative 5. Because those are two numbers that you can square in order to get positive 25. So using that same concept, if you have x minus 2 squared equals 16, this is kind of like vertex form, except the 16's on the other side. So instead of actually doing this out, moving the 16 over and refactoring, if this whole side is being squared, I could cancel this out by square rooting both sides. And now you're left with x minus 2, because the square cancels out the square. The square root cancels out the squared. So we're left with x minus 2. And 16 is both a positive and a negative 4. That's the square root of 16. So now, if I want to solve for x, I can add 2 to both sides. And that gets me two answers. See, I have a positive and a negative 4 plus 2. So x could either equal a positive 4 plus 2, which would be, in other words, 6, or x could equal a negative 4 plus 2, which could be negative 2. And there's how you get your two answers. This is a way to solve quadratics if the whole side is being squared. Because instead of the alternative would be to actually do this the long way, which would be move the 16 over and refactor it, which takes a lot longer of a time. So here is this must be page 8 or page 9 of your packet. Basically, there's two people, Tia and Tahani, and they solved x plus 1 squared in two different ways. Tia did it this way, and Tahani did it this way. You can see that Tahani's method is kind of what we did yesterday. She did x plus 1 squared. She did x plus 1 times x plus 1. She moved over the positive 9 by subtracting 9 on both sides. And then once you got it all, you have it as a quadratic that equals 0, she refactored and solved for, set each one of these equal to 0 and got her two answers. Tia's method, it asks you which one is correct. And it's actually, Tahani did it correctly. Tia did it incorrectly. And can you tell where Tia did it incorrectly? Well, it's what we just talked about. When you took the square root of both sides, she said that the only thing that gets you 9 when you square root is 3. But it's actually both a positive and a negative 3. So Tia's method was wrong only because she forgot that when you square root something, you got to assume that it's both positive and negative. So basically it says use Zach's method to show that this has two solutions. Determine, it says sketch the graph. Remember that when you have it like this, being able to graph it is really important to have our vertex. So I can turn this into vertex form by moving over the 9, because if I move over the 9, I get x plus 1 squared minus 9, which equals 0. So 0 is, in other words, our y, because it's like making y 0, so we're going to be finding our x-intercepts. Right here, we know now that it's in vertex form, we know our vertex is -1, -9, because it's the opposite of what's inside. That's the horizontal translation. This is the vertical translation. So we could put our vertex at -1, -9. And then I can go ahead and I can plug a value for x in on either side of the vertex. So I'm going to make a little table. And this is just another method to actually solve what the x-intercepts are. Okay. When I put in an x of, like, let's see, go to the one to the left, so -2. If I put a -2 in there, I get -2 plus 1, which is -1, squared is +1. +1 minus 9 is -8. Okay. So I get -2, -8, which means there's 1 here, and then on the other side, because there's a line of symmetry. But when I draw my parabola, I'm not quite sure where my x-intercepts are. So I'm not really sure how to find my solution. So that's where we can actually do it on our calculator. If we put this equation in our calculator, but you have to actually set it equal to 0 first before you put in your calculator. So you have to move over the 9. But if I do x plus 1 in parentheses squared, and remember, then we did -9 because we moved the 9 over. Once you have everything over and equals 0, you can graph it. And when you graph it, you could actually solve for x by just knowing what the roots or the x-intercepts or the solutions are, the zeros. To do that, we do second calc, and we look for, you can see one of our options is to find the zeros, which are the x-intercepts. So if you hit number 2, it says left bound. So we want to go, there's 2 of them, so we have to do this separately. Left bound means goes to the left of where the point you're looking at. So right now, I'm right about on the x-intercept. So if I hit left once or twice, I'm now to the left of it. It's actually above it. Right bound, I'm going to hit the right button a couple times till I'm below it. And guess, you just hit enter one more time, and you get one of the zeros is -4. So that's one of your x values, -4. The other one we could just do by using that same method, second calc, 0. But now I'm going to go to the left bound of the other x-intercept. Notice as I'm hitting the right button, it's moving up. So left bound is actually going to be below the point. Right bound, go above it, hit right a couple times, enter, and then guess, hit enter one more time. So we get our answer of 2, -4. So that would be using Zach's method to be able to graph it, because we can solve this equation for x if we just graph it and know what the x-intercepts are on our calculator. So the homework is going to be to complete page 9, and we've done 3 methods. We've done the square root, we've done factoring, and we've done graphing. So remember, just to give you an example, here is one. It's an equation, and we can use 3 different methods. So go ahead and pause the video, and we're going to try all 3 methods. So first of all, Tia's method is where we take the square root of both sides. So we have x minus 3 squared equals 4. You want to move everything over so that you only have one whole side is being squared. If this 4 was on this side, we'd have to move it over. So we square root both sides, and you can get then x minus 3 equals both a positive and a -2. Then you add 3 to both sides. So when you add 3 to both sides, to cancel that out, you get x equals positive 2 plus 3, which is 5. And you get x equals -2 plus 3, which is 1. And there's our 2 answers. Now, Tahani's method is to move the 4 over and then refactor. So watch what we do here. First of all, let's do x minus 3 times x minus 3, which gets you x squared minus 6x plus 9, because -3 times -3. The -6x comes from -3x plus -3x. But this equals 4. So now we have to move the 4 over by subtracting 4 on both sides. That gets you plus 5. Now we're going to refactor. things that multiply to 5 that add to negative 6. That's x minus 3 and x minus 2. Oh, that actually doesn't add to, I'm sorry, did that wrong. Things that multiply to positive 5 that add to negative 6. That would be negative 5 and negative 1. So x minus 5 times x minus 1, which equals 0. And then if I set each one of these equal to 0 and solve for each of them, you get your answer of positive 5 and positive 1. You'll notice we got the same exact answer that we did when we used Tia's way, because just different ways of doing the same thing. Zach's method is to get the vertex by moving the 4 over. So if I subtract 4 on both sides, now I know that my vertex is at positive 3, negative 4. And then to find out the x-intercepts by graphing, I'm going to go to my calculator and plug this equation in. So it's x minus 3 squared, then minus 4. Hit graph. Second trace, which is calculate the zeros. Left bound, I'm just going to do 1 because you're going to get the same answers. Left bound is going to go to that point. I'm going to go to the left of it, which is above it. Enter. Right bound below it. Enter. And lo and behold, we will get 1, 0. And if we did the same thing to the other side, we get 5. Same answers that you would get either way. And that would be Zach's method. You can try this one too if you want for extra practice, but your homework's going to be doing the same thing. Try this one on your own. Pause the video, try this one, and then replay it. And I'm going to go to the next page, and I'm going to do it right now and show you the answers. And this will be the warm-up for tomorrow.